and go. So we are working on a tree hazard inventory for recreation management. And the big $1 million question is, are any of the potentially millions of trees in our forested protected area, our national park or wherever, are any one of those individual trees tall enough and potentially sickly enough to hit somebody and kill somebody? That's it. It's either a yes, this is close enough and tall enough to hit our campsite or our picnic table or our resting spot on the trail, wherever it is, or it's not. So we can have a really tall tree, but if that tall tree is far away, it's not tall enough to hit us. We can have a really small tree, but if it's right next to us, it is tall enough to hit. So we combine and speed up measurement of our distance from the tree, this big old oak over here, and the height of any given tree by measuring the angle from horizontal, called the inclination, to the very topmost leaf of that tree. And if that angle is higher, is more open or more obtuse or open angle than 45 degrees, is going to be our magic number. If it's steeper from us to the top of that tree than 45 degrees, or 100% slope, we'll see that in a sec too, then that tree is both tall enough and close enough to hit us, at least with that top leaf. And that's enough to potentially hurt somebody if the top of the tree is falling at a few hundred miles an hour. The bottom of the tree is hinging very slowly, of course, but the top is moving pretty fast if it's a tall tree. So we can measure this very, very quickly and easily a couple of different ways. First, let's use an analog clinometer. So a clinometer measures the incline or decline from the pivot of the gauge itself. So this has a little window on the side, and we're going to hold this up, window facing sideways, to our left. And with both eyes open, one eye looking at the top of the tree, and the other eye looking through the eyepiece into the gauge, we'll see two numbers. On the left-hand side of the dial, we're going to see a smaller number, in this case, 40. That smaller number of the two is going to be the degrees. The larger number of the two that you see inside here is going to be the percent slope that is equal to that degree. All right? So, the very topmost leaf of that tree is about 40 degrees up from horizontal from us, which means that even though this is a really tall tree, probably over 100 feet tall, it's not close enough that if it falls, it's going to hit anything. So that's a safe tree. Even if it's sick, we don't care. Now, a much smaller tree, like this right next to us, is not nearly as tall as that big oak over there, but it's also much closer. So it's shorter but closer. So we do the same measurement. We hold the clinometer with the window open to the left, both eyes open, look at the topmost leaf of the tree, and that number is over 45 on the left side of the dial. It's over 100% slope, or percent inclination, on the right side of the dial, which means that this tree is pretty short, but it's close enough that if it does fall, it could hit somebody, hit one of your recreating guests, and kill them or their whole family or the dog, and it's a big tragedy and everybody's upset. And it happened on our watch as the park ranger. So this is why we do this. And if the tree is too far away, meaning the angle from our eye to the top of the tree is less than 45 degrees, the left number on the dial, then we don't care if it's sick or not. If the tree is within or higher than 45 degrees to the top leaf from us, then we do need to do a little bit more investigation. For a tree that's healthy and close enough to strike, that's not necessarily a problem, right? There are lots of trees in a forest, and we go walking in forests all the time without injury or problem. A healthy tree is okay. But if the tree is angled, its topmost leaf is angled at higher than 45 degrees, and it has any signs of disease or injury or structural malformations like a low splitting trunk from a top budded sapling, for example, then that's both capable of killing your guests, and it has more of a reason to from that injury or that structural malformation, like it's growing on a slant instead of straight up and down, and there's a lot of lateral loading on that trunk and so forth. So it might just take a windstorm or an ice storm or nothing at all. Maybe a squirrel just jumping from a diseased branch to dislodge that branch right onto a tent. Okay, so that's the core of this project, right? So we have another way to assess this with modern technology. This is a TruePulse 360 laser hypsometer, and it's doing exactly the same thing that our analog clinometer is doing, but it's going to require batteries, but it can do math for us. So this has a bunch of different functions, and if you're using this for your class exercise today, I want you to adjust the objective or standoff from the lens until it's comfortable for your eye. Adjust the focus with the inner knurled ring. Usually all the way clockwise is most in focus, but your eyes may be different. And then press the top center button once to turn it on, and use these arrow buttons up and down to select the different modes. This does all of your Forestry 351 forest mensuration stuff, like height, distance, number of sticks or logs, that kind of thing. We just want the inclination. We just want that angle. Is it above 45 or not? So turn it on. Sight with one eye to the top of the tree, and press and hold, and it'll send out a bunch of infrared laser pulses, and we get 53.1 degrees. So that's higher than 45, and that exactly agrees with what the analog device did. So, two different tools, same measurement. And if we measure our original oak tree way up there, that's going to, so press and hold the button when the mode says INC, or inclination, at the bottom. And that gives us 40.0 degrees, just like the analog unit does. So, again, if it's below 45 degrees, it's too small and or too far away. We don't care about it in terms of safety risk. It might still be a forest health risk, whatever. But in terms of killing our guests, it is not a problem. If it's higher than 45 degrees, it is too close or too tall or both, that if it hinges at the ground, it will hit and potentially kill somebody. And with Murphy's Law, right, if the tree falls, it's gonna be at that moment when somebody happens to be walking underneath it. All right, if you have any questions, ask your instructor, and try a couple of different techniques or measurement tools with it. If you want to get more sophisticated and get into the trigonometry of what's the distance to the base and the angle to the top, to compute using trigonometry what the height of the tree is versus its distance, you can do that. But for our purposes, more or less than 45, and you're good to go.